So, what we want to do is look over the sheet. Obviously, we had all the answers given, so that's not a big deal. But we're just going to go over kind of a section at a time, and I'll see what questions you have, and we'll go over whatever problems. And I'll try to at least do one on the board from each section. So, 1 through 6, any questions there? The biggest thing is noting, like for number 5, if you did number 5, when you looked at it, the information given is this, and not just saying trapezoid, but saying isosceles trapezoid. Because we always want to be more specific than necessary. So 5 should probably be isosceles trapezoid, not just trapezoid.
Really quickly, I kind of forgot the difference between a regular trapezoid and isosceles.
This is isosceles because the two legs are the same length. That's why it's isosceles. A regular trapezoid might be something like this. Okay? I still have one pair of parallel sides, but the legs are not the same.
Okay.
Okay? How about 7 and 8? 7, 8, 9, and 10, we'll take them. Well, 7 and 8, where the mid-segment is the unknown part. Any questions there? Just as a quick review again, if I have a trapezoid, let's go ahead and draw one kind of like number 8. Okay. So we had 13.4 and 7.8. Remember the mid-segment, to find the mid-segment, we're going to add these two, which would be 21.2, and divide it by 2. And we'd actually calculate that out, and that's what, 10.6? So a little bit tougher when we got the decimals there. We do have to know our formula and how to set it up, but it's not that much more difficult. How about something like number 9? Can you get 9? Well, with 9, the short side was 15, so kind of a similar picture. Short side was 15, and this was 21. So what's the long side going to have to be?
7.
Because what's the difference from here to here? 6. So the difference from here to here also has to be 6. That's the easiest way to do it. The other way of doing that, if you wanted to, is you could have said x plus 15, use the formula, divided by 2 equals 21, and then multiply both sides by 2. And if I subtract the 15, I still get x is 27. But for the most part, we can usually just find the pattern.
Like we won't get points marked off.
If you just use the pattern, that's fine. That's kind of how I taught you how to do it. But there's nothing wrong with the formula. There's nothing wrong with using the formula. You just don't need to in most cases. Starting with 11 through 14, now we had some variable expressions involved as well with these. And again, I'm just going to draw a general trapezoid just so we with a mid-segment, so we can just throw things in there. But like I said, say number 12, 7 plus 2x. We had 17 and 27. If I know 2 out of the 3 sides, I'm not going to generally bother with a big formula because the algebra is going to be messy. I'm just going to look and say, oh, 27, 17, this has to be 7, right? So 7 plus 2x has to equal 7. And there's all the algebra I have to do. X is going to have to be 0 in that case, isn't it? And by the way, I remember on the last quiz we had a problem where x equaled 0, and that people kind of struggled with that idea a little bit. They're, wait a minute, 0. I must have done something wrong. No, 0 is fine. Just another number. It can be 0. All right. So generally with those, again, just figure out what the side has to be and then substitute that in to set up a simple equation rather than making it more complicated. 15 through 20, again, we had trapezoids. And I'm just going to kind of substitute in, but like for 18, I had maybe like this angle is 105, and this is x down here. And again, remember with a trapezoid that these sides are parallel, which means these are consecutive interior angles. Obviously, they aren't going to be congruent. They're going to be what? They're going to add up to 180. So x is going to have to be 75 in this case. And 15 through 20, we're pretty much always doing that. Just take 180 minus whatever they give you, and it gives you the other angle. Diagonals of a trapezoid. Remember, if the trapezoid is isosceles and all these are, the diagonals are congruent. So we just set those two measurements equal to each other. So for 21 through 24, you took whatever two segments they gave you and set them equal. So like 24 was 21 equals 4x minus 23 is the equation you come up with. Now, that only applies in isosceles trapezoids. In a regular trapezoid, the diagonals are not congruent. I'm not going to give you one of those, but just remember that. In general, the diagonals of a regular trapezoid are not congruent. Only the diagonals of an isosceles trapezoid are congruent. Back page, the kites. I want to do a couple of these. If you ever have to draw a kite, the easiest way to do it is to draw like a cross first and then connect the points of the cross. That's the easiest way to draw a kite. And for something like 25, we had 13 here, x here, and 5 over here. Now, what do we know is special about the diagonals of a kite? They have to be perpendicular, which means that this forms the right triangle. Problem is, I don't have the measurements in the right place, but I know the diagonals, that one diagonal bisects the other one. Clearly, this one is not being bisected. Those two parts are not equal. So these two have to be equal. That's the 5. And then we just have Pythagorean theorem. 5 squared plus x squared equals 13 squared. So I subtract 25. And I get x squared is 144. Whoops. There we go. So x is the square root of 144. In this case, that's a perfect square, 12. All right. 27 and 28 were very similar to that. 28 actually didn't even require Pythagorean theorem. 27x is just 6. Or 28x is just 6. It's congruent with that same other point. There's just extra information there. The 19 and the 7 aren't even necessary information. So you have the 6 on the left. This x must be on the right. Let's talk about the angles very quickly of a kite. So, like I said, drawing a kite is easier if I draw in the cross first. Okay, let's get rid of those parts. Okay. So, angles of a kite, we had like number 26 where we had 110 right here and 60 right here. And it asks for x down here. Well, remember that there's one pair of congruent angles on a kite. Is it going to be 60 and x? No, it's going to be these two. It's where the non-congruent sides connect. Those two angles have to be congruent. So this angle also has to be 110. And what do the angles of a kite add up to, all four of them? 360. So it's 220, 280, 360 minus 280 is 80. Okay, obviously not drawing the scale. So that's the way it works. For number 29, we switched up a little bit. Just use the same picture. I was told one was 40 and one was 70. Okay, that's 110, leaving me 250 degrees left, which means the other two angles are each what? 125. Now, of course, the other thing that's going to show up on this quiz that wasn't on here, because we've been doing a lot of it, but I still want to review it just a little bit. Let's check in here. What time are we supposed to be out of this? It's about the same as a normal PLC. So I think it's, hold on. I've got the schedule right here. Well, actually, we got a lot of time still. We got 20 minutes still. We're going here to 12:15.
What?
So we got lots and lots of time.
You know what we should do? I think it would really help me figure out how to find the end of the kite. We took a kite out and pulled it a little bit. Really,
You can go out and do that any night after school you want. It's just fine.
you know, that would really just get me to know.
Then by all means, go buy yourself a kite, go out and fly it, have a great time, and then tell me what you learned.
The best thing to do would be to walk by a person who's flying a kite before
You're mean. Okay,
that would make me cry.
let's just destroy someone's happiness. There we go.
Over a kite. Punch first, ask questions later. What if a bomb on your kite? Then it won't be able to fly. It's a small bomb and a big kite. Micro-sized bomb? No.
Why are we talking about bombs?
Yeah, that's like totally inappropriate, guys.
Just as
Okay, here's A, B, C, D. What type of a shape is it? Well, first thing we do, given the points, is we draw it. And based on our drawing, we're going to have some sort of idea of what it might be. Based on that picture, what do we think that shape might be? Might be a parallelogram, might be a rhombus, could be rectangle. Okay, we have to determine what exactly it is. How would you like to go about proving what type of shape it is? Okay, slope will give us the slopes of the sides until the top sides are parallel, so we can do that. So AB, slope of AB, will be 4 minus, that's negative 2, positive 2, sorry. 4 minus 2 over 3 minus negative 2 is 2/5. Slope of BC, 4 minus 2 over 3 minus 5, which is 2 over negative 2 or negative 1. Slope of CD, 2 minus 0 over 5 minus 0 is 2/5. And the slope of DA, positive 2 minus 0 over negative 2 minus 0, which is negative 1. Aha! Opposite sides are so these two are parallel. These two are parallel. It is a parallelogram. So that tells me parallelogram. What else is that telling me from the slopes? What is it not based on the slopes? It is not I don't know that yet. It is not a rectangle because consecutive sides are not perpendicular. It's a parallelogram, not a rectangle. The question is it a rhombus or not? And to do that, the only way we can prove that, there are 2 different ways. I can see if the diagonals are perpendicular or not. If they're not perpendicular, it's not a rhombus. If it is, the other way I could do it is by finding the lengths of 2 consecutive sides to see if they're congruent. But either way, it's going to take me 6 measurements to show. I've only got 4 right now. This is going to require 6. So for a lot of people, what they'll do would be to show that AB and find the actual length of AB.
Wait, that's distance.
Yes, length is distance formula. So that'd be negative 2 and 3, and 2 and 4. Negative 2 minus 3 is negative 5. Negative 5 squared is 25. Negative 2 minus 4 is negative 2. Negative 2 squared is 4. That's the square root of 29. And BC. Okay. 3 and 5, 4 and 2. That's negative 2 squared plus 2 squared. Square root of 4 plus 4 is the square root of 8. So since the consecutive sides are not congruent, it means all my sides are not congruent, which means it can't be a rhombus. So it can't be a rhombus. It's not a rhombus. It's not a rectangle, but it is a parallelogram. And that's the most specific name we can give it. No, it's not a kite. It's a parallelogram. I mean, we showed this parallelogram right here. Both pairs of opposite sides are parallel. We've already done with it then. So we already knew it was a parallelogram. We're just trying to figure out what type. In this case, just a plain old parallelogram. But again, remember, the only way we can justify that is with measurements, and it's usually going to take us 6 to prove what something is. We may be able to do a kite with just 4. Trapezoid will take 6 to determine whether or not it's isosceles or not. The only one we can usually do with 4 is a kite. But again, graph it first, then work with it from there. Is there anything else you want to go over? Yes. Yes.
Number 28 would be 6, right? 6 and that's 3 equals.
Yes. And like number 30, x plus 3s equals 13. So x is 10. Yes. Other questions about this homework that are for everyone? Okay, tomorrow is the benchmark then. Make sure you're coming prepared for that. It's a little bit longer than most of our benchmarks. It's like 13 or 14 questions instead of just the regular 10. Still 100 points either way, so it doesn't really make a difference. But we will have pretty much the full class period to do that tomorrow. If I look on the assignment sheet for today,
We have a homework assignment?
I'm just double checking to make sure. We do not. Nope, just CPAS testing, so no homework tonight. But I would definitely be reviewing that worksheet and your homework in preparation for this. A lot of you did not complete the review worksheet, so do it tonight. Show it to me tomorrow. You still get 2/3 credit. So yes, question. Number 13. Yes. What would that length have to be? 3x plus 24 would have to equal, what's halfway between 21 and 27? 24. So 3x plus 24 equals 24. So x is going to be 0, actually. All right. Cut off the podcast.